Let me start by saying that anything that I will be talking about here are my own personal views, and they do not represent the position of Bank of Canada. Now that we got this out of the way, what I do want to talk about today is blockchain. And I'm sure you have all heard about blockchain, the so-called technology behind Bitcoin, a great technology that offers us a public, permissionless, and distributed ledger. So what does it mean? Distributed means that anyone can, that many people can write into the database, into the ledger, can write new entries. Permissionless means that there is no entity that would restrict who can write and who cannot write into the ledger. Nobody giving permissions to write into the ledger. Public means that anyone can read the ledger as it is written. Moreover, you probably have heard that blockchain cryptographically assures immutability. This is a technology that is going to make sure by cryptography that nothing can be changed. It does all of this without the need for trusted third party, and it also allows for smart contracts. So great technology, awesome, except, it would be great, except about half of those things are not really true. Now, as we talk about blockchain, we expect great benefits, and especially we expect cost savings. Cost savings were supposed to come, this is where we expect them from, increased security, because it's immutable. Immutable means nobody can change it, it's secure. It is going to come from faster transactions. Now we can do our transfers almost instantaneously. And most of all, the shared ledger is going to let us cooperate between different companies, entities, without the need for trust. And it's going to lead to democratization, decentralization, and disintermediation of the business space. So we can get rid of intermediaries. This is going to save costs. So while those premises are well argued, they actually confound three different separate concepts under the banner of blockchain technologies. They confuse cryptography and encryption, confuse automated execution of transactions, which are also called smart contracts, and distributed ledger, which is a type of distributed database. And those are three very separate things. And what I'm going to argue is that it is really important to look at them separately, because they all bring different benefits. They're responsible for different cost savings arguments. And in fact, they can be implemented separately. So they shouldn't be put into one bucket as blockchain technologies, because what we are getting are arguments that are half-baked and not completely true. And we are getting lost into where the benefits of blockchain is actually going to come from and where the blockchain is going. So if those are three separate concepts, what is blockchain then? I'm going to say that blockchain is a distributed ledger of transactions. And that means that this is a type of distributed database that keeps the history of all the transactions rather than just balances of accounts, the summary of balances. So this is the only requirement that I'm going to put on the database here. For the techies out there, this would be called a distributed append-only database. Now, if I keep this definition so parsimonious, I'm going to allow many, many blockchains or many, many databases to be called blockchain, but they may or may not be able to be kept secure without a trusted third party. Now, Bitcoin's blockchain can be secure, immutable, without the need for trusted third party. But many blockchains that do not involve native cryptocurrencies cannot really do it. So Bitcoin's blockchain has other attributes than just being distributed and append only. It is public, anyone can see into it, but most of all, it is permissionless. Nobody restricts who can write in Bitcoin's blockchain. Now, this attribute, the permissionless, is really important attribute of Bitcoin, because distributed databases, and distributed ledger is just one type of distributed database, have been developed about 4 decades ago and have been used extensively. Every single internet company is using distributed databases and have been using it for as long as they have more than one server, right? So this has been around for a long time. The thing is that all the traditional distributed databases always needed trusted third parties, always needed somebody to keep an eye on what's going on, to resolve conflicts, and at the minimum to set the permissions on who can change the data in the database or not. And Bitcoin was the first one to allow for permissionless distributed database. So this is the first time that we can have a system that really does not need a trusted third party. So the question is, if this is so important, why do I set the definition that does not include permissionless? It just says distributed. Well, we can alternatively just say that blockchain is a permissionless distributed ledger. But if we do that, it turns out that we don't have any applications except for cryptocurrencies. Right now, none of the applications that you may read about extensively would fall under this definition. Then we wouldn't have much to talk about blockchain. So why is it the case that blockchain can be permissionless and can really be without trusted third party, and other blockchains cannot pull it off? The answer is blockchain is not really a technology. It's not that there is an independent technology called blockchain and Satoshi Nakamoto just stuck Bitcoin on top of the blockchain. That's not the case. Blockchain is an outcome of the system. So Bitcoin's blockchain uses cryptography. So yes, it uses cryptography, but Nakamoto himself or herself or themselves, we don't know, was saying we are using the usual framework for coins. The cryptography tools used in Bitcoin's blockchain are quite simple, and they have been known many years before Bitcoin's inception. The reason why Bitcoin finally cracked the issue, cracked the problem of how to create the permissionless database, distributed database, was combining simple cryptographic tools with incentives, with incentive system. Basically, Nakamoto says, we have very usual coin framework, usual framework for coins. This is typical. But what really provides security is the fact that it's computationally impractical to attack the Bitcoin system. Hasn't been using the word blockchain yet. And in fact, it is not true that it is cryptographically assured or cryptographically technically impossible to fraud the blockchain or to falsify the blockchain. It's just not economical to falsify the blockchain. It means that it is only immutable with some probability, not guaranteed. And this is how it achieves the permissionless. Has some other restrictions, but achieves permissionless without the need for trusted third party, and it works for all practical purposes. And it works only because it is part of the Bitcoin system. And the Bitcoin system includes also proof of work and mining and rewards for mining. Proof of work is just requiring a lot of computational power and so-called wasted effort. But in fact, it's not wasted. It is a crucial element that assures immutability or allows for immutability of Bitcoin's blockchain. Now, what we would like to see, or what people erroneously extrapolate, is that any blockchain is going to have these properties. But here's a problem. if Bitcoin's blockchain is the outcome of the incentive systems combined with cryptography, then the moment we are changing the system, we are going to be changing the properties of blockchain. The moment we are taking away Bitcoin, the moment we are taking away proof of work, we are taking away mining, we are changing something, and the resulting blockchain is not going to have all these properties. And most of all, it's going to use permissionlessness. So a side note is that if you look into the Bitcoin's blockchain, smart contracts are not part of Bitcoin's blockchain. They are very useful, but they don't need the blockchain. They can be implemented on a centralized platform. Cryptography is simple, and it's only a small part of providing security. It's not where the security is coming from. It is important to distinguish those elements because the smart contracts and encryption has been developing very, very rapidly and has a lot of benefits, but the benefits can be implemented without the blockchain. So what are the benefits of distributed ledger? So benefits of blockchain. There are in places where we want multiple parties to write into a ledger and we want to make sure that the changes in the ledger are reflected across those multiple parties, right? Typically, distributed databases have been used within companies because there always needed to be trusted third party to make sure that everything works properly and there are no glitches. Now, we are looking for implementations of blockchains across companies because we hope that we can do it without the trust. And then the biggest benefits are where the reconciliation of contradictory ledgers would be very costly. So if you think about the banks trying to reconcile their contradictory ledgers, a lot of money gets lost or tied up in the process. This is where having a shared ledger, having a distributed ledger would be really helpful. But it comes at a cost. So if we have distributed system, there is the system is less speedy than a centralized system. There needs to be replicated storage of the ledger. Everybody needs to store the same information, lots of duplication. It's actually difficult to find information if we keep the whole history. And the information is visible to everyone. This is not always good. So some people say transparency is the benefit of blockchain. Well, we need to be really careful about those implementations. Now, the expectations of blockchain are larger than just distributed ledger. We want to have all those benefits that Bitcoin has and be applied in settings other than cryptocurrencies. Now, this so far has proven to be a challenge. For several reasons. Let me name just a few. First of all, if we want to use blockchain for assets different than the cryptocurrency that is born on the blockchain and lives only on the blockchain, we need to have a way to put those assets on the blockchain. Well, if somebody is going to do it, we need to trust this party to put the information on the blockchain. So we need a trusted party, number one. Then we need to make sure that the system is immutable, so secure, because if we have a system that anyone can write into and they can write arbitrary things, it doesn't go very far. Now, if we are going to put very valuable assets on the blockchain, and the valuable assets could potentially be stolen, the more valuable assets we are putting on the blockchain, the more incentives attackers have to steal the assets. Now, the blockchain, Bitcoin's blockchain, is an incentive system. So somebody has to provide incentives for those nodes that participate in maintaining the blockchain to make sure that they themselves do not steal it, right? To make sure that they do not allow anyone from outside to steal it. This is going to be costly. Somebody needs to provide these incentives. If this doesn't come from the native cryptocurrency that comes from the blockchain, like Bitcoin, then who is going to put in the resources? And once the institution or entity puts in the resources, we need to make sure that we are trusting that entity. Moreover, blockchain does not substitute for unreliable institutions. So if you have heard, let's fix problem in Kenya or in Peru related to real estate. Let's put all the real estate on blockchain, and now it's going to solve the problem of misappropriation. Well, if the government does not honor paper books, they are not going to honor an electronic ledger. No matter how wonderful the technology behind it is, blockchain is not going to solve these problems. And the truth is that so far we do not have a technology that offers permissionless distributed ledger that cryptographically assure immutability without a trusted third party. We don't. And the solution until now has been, in all the applications that are not cryptocurrencies, was to set up so-called permissioned blockchains. And you have probably heard this is a private blockchain, this is permission blockchain, this is our own blockchain. Now, all those blockchains need a trusted third party, at the minimum, to set up the permissions. Because if it's permission, then it needs to start somewhere. Now, we can discuss different levels of involvement of those trusted third parties. But the bottom line is that every single of those blockchains needs one or several. And sometimes they have very active involvement, and sometimes they are gatekeepers. But either way, we are back to the old-fashioned distributed databases with, yes, they have progressed, so we have new developments in this space, but what I really want to point out is that we need trusted third parties. So where does it take us? If we are looking at the future of the blockchain revolution and blockchain technology, then we should expect increased application of distributed databases and an attempt to really implement distributed databases between independent companies to foster cooperation and collaboration and reconciliation of shared ledgers between companies that do not that could not have cooperated so easily before the blockchain. But it's not going to be maybe in different forms than the ledgers and maybe databases, but they are unlikely to be permissionless because we cannot really make them work so far. There is work done on that, but 10 years on, we have not succeeded so far. And if we need to rely on some sort of trusted third parties to foster collaboration and cooperation between these different companies, potentially many different companies, then we should think about another communication technology that we have heard about that is going to democratize, decentralize, and disintermediate the market, and it's going to help to do all those great things. This was the internet, and it delivered on many aspects, at the same time creating more powerful intermediaries than ever before. So Facebook's, Amazon, Google's, and so on. And now we actually may be facing even more powerful communication technology that is going to help coordinate not between individuals, as Facebook does and so on, but between companies. If those intermediaries are going to have a focal place, then they will be even more powerful than without the blockchain. And this is something I want to emphasize in terms of our thinking about the future of blockchain. Another 2 points that I want to kind of mention is that, yes, the blockchain revolution is going to give us more smart contracts and more advanced encryption because we are paying more attention to it. But those two do not need to be related to blockchain. They're just popularized. So thank you very much.
so much. We'll open for questions.
Hi. I'm wondering if quantum key distribution is a potential technology for building a key exchange as an alternative for blockchain. And I'm also wondering, as a follow-up to that, is there a relationship between blockchain and VR as an application platform? Can we use blockchain to implement VR technologies as a follow-up? Yeah.
So when it comes to quantum computing, then it may allow us for different cryptography tools. And I mean, it's hard to say where our quantum computers are going to take us. So far, we struggle to make them add 2 plus 2, and sometimes it works, sometimes it doesn't. But they will definitely change all the cryptography tools. And then the question is, could they provide a system that cryptographically assures that nothing can be changed once you make a transaction? Now, it's open for grabs. When I say that we don't have the technology right now, maybe we don't even need the quantum computers. Maybe there is still possibility that we are going to come up with a system that assure immutability of the ledger without the need for incentive system, just based on cryptography tools. But as long as you get incentive systems, then you need to look very, very carefully about how you are changing the system and what does it do to the outcome.
I'm just wondering, on the one side, we are moving towards the cloud where the power is going there and all the centralized processing is happening there. On other side, we are talking about this blockchain where you're talking about distributed computing and all. So do you see some synergies between these two technologies going to complement each other in the future in terms of what applications comes out and other utilities there?
So what was the first one?
So one is a cloud, right? So you're moving towards the cloud where all the central processing is happening, right? Because of the more computing power and everything. And everyone is trying to move there. On other side, you are talking about the blockchain where you distributed computing you are talking about, right? So do you see any synergies between these two technologies?
So I would say that definitely a historical example, because isn't cloud computing that is now being centralized, increasingly centralized, it came from internet that we expected to decentralize things. So we don't need to implement the technology, because whether you are going to run, of course, you can run blockchain on the cloud. You can have more different entities running different nodes on the cloud that are actually gathered and really run by Amazon. So how decentralized is that? So this is basically connecting the technologies. But what I want to draw is more of a historical analogy. Is with technology that we expect to be decentralized, very often we see even greater centralization.
Thank you for the talk. It occurred to me that a lot of these conversations go in sort of this cyclic pattern where we explain the technology and we try to be technologists, but then in the long term, I'm a business person. I'm not trying to be a data architect, right? And we never really end up at the uniqueness of the application, or what unique application are we able to assign to blockchain so that all of its capacities combined actually do something for me, right? So immutability in like the Mango supply chain, not that important, or cryptography, we have other aspects of that. Like, where are we actually using this at the enterprise level? Distributed databases, you've sort of made your point, Newt, there, because those all exist as well. Could you just describe, from a business perspective, what can I do with blockchain that I can't do with any other existing technology, either holistically or in part?
Right now, cryptocurrencies. and that's the thing. We don't have a killer application, right? So yes, we could have, we want immutability. Look, any database that does not have immutability is only as good as open Google Doc, right? Where everybody can write in and potentially vandalize. So if you trust your friends, then they can all write in. But if it's not immutable, then it's not useful for business applications. So it has to be immutable. How is it going to get there? How are we going to achieve immutability? This is, I mean, those are important things. But right now, when it comes to blockchain, if it's not cryptocurrency, then we are just doing distributed database. So all the applications that I had seen as blockchain for supply chain is basically tracking system, which, sorry, but FedEx and UPS have had it for longer. So this is not really so inventive. And that's the thing, is we would love to see permissionless, so the one that does not need trusted third parties, so that if we have a database like this, we can write real estate ledger and make sure that nobody changes it. It's just, so far it has not, we have not seen a technology that would allow us to do it.